Hey you guys, I just wanted to give you a couple quick notes on lesson 8.7, which is going to be trying to work with inequalities, but with word problems. So I put two on here. I did one regular inequality word problem just to remind you guys how to create it from the actual story and to solve it and then graph it and shade. And then I did a second one on the back. That's a system of inequalities. That way you'll have to do two of them and graph them at the same time and then see where the shading overlaps. Okay, so for this first one it says, suppose your class is raising money for the Red Cross and you make $3 on each basket of fruit. Now since I realize we're selling fruit, I'm going to go ahead and declare a variable that says that X is going to equal however many baskets of fruit that I sell. And then it says we make $5 on each box of cheese. So since we're selling cheese as well, I'm going to make that a variable and let Y be each box of cheese. So now I have two variables declared and I can create an equation. It says how much of each item should you sell if you want to raise, keyword, more than $100. That means I can't raise like $99 or $98. I can't even raise 100. I have to raise more than 100. So if I set this up, I can see that it's $3 for every basket of fruit, which I called fruit my X value, right? So basically $3 for every box of fruit, but then I get $5 for every box of cheese, which is my Y value. So I get $5 for every box of cheese. And I have to sell more than $100 worth. The question is, should I make a symbol like this, or should I make a symbol like this, right? That's the question. So now if you guys remember, whichever side is open, right? So like this side here, you guys see how it's open? That would be towards the bigger value. So if I want my money to be more than 100, I should keep the sign the way it is right now. That way my equation says 3x plus 5y is greater than 100. So now I need to put this in a slope-intercept form so that I can solve for the y value, and that's going to allow me to graph this. So let's get this thing into slope-intercept form. I can subtract this 3x out of my way, which means I'll have to subtract it over here as well. So now these 3x's cancel each other. That will leave me with a 5y that is now greater than a negative 3x and a positive 100. I'm one step away from slope-intercept form. If I divide this by 5, I'll have to divide this by 5, and I'll have to divide this by 5, which means these 5's cancel, and now a y value will be greater than a negative 3/5 x, all plus 100 over 5, which is 20. So this is really good slope-intercept form here. Now I can graph. To graph, I'll need two things. I'll need to plot my y-intercept, which is here, right? This is the y-intercept. And I'll have to count out my slope, which is rise over run, and that's here. So I'm going to put my y-intercept at 20, like this. And then I'm going to start counting a rise of negative 3 and a run of 5. So I'll rise negative 1, 2, 3, run 1, 2, 3, 4, 5. There's a dot. I'll do the same thing. Rise negative 1, 2, 3, run 1, 2, 3, 4, 5. There's a dot. 1, 2, 3, 1, 2, 3, 4, 5. There's a dot. 1, 2, 3, 1, 2, 3, 4, 5. Here's a dot. 1, 2, 3, 1, 2, 3, 4, 5. Here's a dot, and we're almost done, I promise. Rise 1, 2, 3, 1, 2, 3, 4, 5. That should be plenty to get me off my edge of the graph. I'm going to go ahead and erase all the slope dots that I counted just so it's kind of cleaned up a little bit. You want to think about whether this should be a dotted or a solid line. Now, because my inequality did not have a equals to sign underneath it, I should go ahead and just make this a dotted line, right? There's no need for solid. And that's because, again, if you looked at your inequality symbol, which was, sorry, I'm just trying to change my pen color, the greater than symbol, there's no equal to. So I'm going to go ahead and put a line through my dots that I sloped. That way I can get to where I need to be. So go ahead and just put a line all the way through these dots here. And then just decide now, should you be shading above or below, right? And since the symbol is greater than, you would want to be shading everything above, right? So shade everything up here. And now this basically tells you all of the potential areas where you could make over $100, right? And that would be by shading above the line, okay? So the next example then would help you guys do a system. So this one says that Joanne likes her job. Oh, you know what? On the back, that's my apology. This should be dotted. So I'm actually going to take an eraser. I'm sorry. This should be dotted. So I'm going to take this eraser and actually just dot this thing up. Right? It should look more like that. And then you should still shade above. But now it's a dotted line. Okay? So then on the back, you have a system, like I said, so there'll be two of them. So on the back, let's set up our equation. You're going to have to declare variables first, of course. So it says Joanne likes her job as a babysitter. Already I can see she's babysitting. So I'm going to let X be any time that she babysits. Okay, babysit. She makes $3 when she babysits, so we'll remember that for later. She also has a job as a tutor. So I'm going to make sure that I know when she tutors as well, because she has two jobs. One's babysitting, one's tutoring. That pays her $6 an hour. That's important. So basically, like, babysitting is going to be $3 an hour. Tutoring is going to be $6 an hour. It says because of school, her parents will only let her work 15 hours a week. So already I know the amount of time she babysits plus the amount of time that she's going to tutor has to be less than 15 hours. Her parents will not let her work more than 15 hours a week. But then the other problem set, the equation would come from how many hours can she work if she wants to make $66 a week? Well, don't forget, now that we're talking about money, every hour she babysits, she makes $3. And every hour that she tutors, which is Y, she makes $6. And she wants to make sure she makes more than $66 per week. And she actually says she wants to make at least 66. So it's okay if she does make 66. So I can actually put an equal to sign, because if you make 66, she'll be happy. I now have to graph both of these and put them on my coordinate plane and see where they cross each other and shade, so I know all the possible hours she can work that will allow her to, first of all, work less than 15 so her parents are happy, but then also make more than 66 a week so that she's happy, right? So I have to put both of these into slope-intercept form. I'm going to start by doing the x plus y is less than 15. So let me change color for a second. So if x plus y was less than 15, I could get that in a slope-intercept form with one simple step. I would just subtract this x out of my way so that it canceled, and then y would actually be less than a negative x plus a 15. So you're in slope-intercept form there. We'll graph it in a second. To get this other one into slope-intercept, which was 3x plus 6y being greater than or equal to $66 so that she can make her money, this one takes two steps. This one you have to move this 3x out of your way so that it comes to the other side, because it'll cancel. But that actually leaves you with a 6y being greater than or equal to a negative 3x that gets added to 66. You still have to divide this 6 out, and divide this 6 out, and divide this 6 out, so that you'll be in slope-intercept form. So that would look like this. The 6 is going to cancel itself, which means y is now greater than or equal to, if I simplify a negative 3/6, it's actually just a negative 1/2 with an x. And then, of course, 66 over 6 is an 11. Now you have two inequalities that are in slope-intercept form that you can throw on a graph here, which I'll do now. So let's color code a little bit better. I'm going to do this as an official like red equation, and then I'm actually going to change this one to a purple equation. That way you guys can keep everything organized. So I'm going to make this one my purple equation. I'll do purple first. The y-intercept of the purple is right here at 15. I'll put a note that says y-intercept. So that means the y-intercept is at 15. So I'm going to put it right here. And then the slope, if you notice, is right here. And even though I don't quite see it as a slope, I can slide a 1 right in front of the x value, which means I should slope negative 1. And I'm going to zoom in a little bit so I can actually slope negative 1. So let's slope down 1 over 1, down 1 over 1, down 1 over 1, and then you guys can do this pretty quickly once you get the hang of where it's headed. So basically this line right here is going to tell me all the areas where she can work for a certain amount of hours and stay under that 15 hours per week limit. So it's supposed to be a dotted line, so I'm going to just connect every other one, if that makes sense. And then I'm going to go back and check the symbol to see if I should be shading above or below. So if I look at the purple circle line here, do you guys see this value here? If you guys remember from class what we talked about, this value here should be a less than symbol, which means I should be shading below. So let's shade everything below the purple line. Basically like everything down here. Okay, now we got to do the red line, which it has a y-intercept at, well, the y-intercept is here at 11, right, y-intercept, and the slope is here at rise -1, run 2. So let's go put a y-intercept at 11, and then let's slope down 1 over 2. So y-intercept at 11 right here. Now down 1 over 2, down 1 over 2, down 1 over 2, down 1 over, there's your intersection, but I'm going to keep going, down 1 over 2, 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 and you're about there at 22. So then if I draw this line in here, it would pretty much come all the way across. You guys will notice from the equation, you guys will notice from the equation that this is actually a solid line, and that's because your inequality was greater than or equal to 66, right? It was like greater than or equal to 66, which makes it a solid line. And then let's check the direction to see where I should shade. For this one, you guys will notice that your direction is actually greater than or equal to, which means I should be shading above the line. So let me grab a red, and I will shade above this line. And then just find out where the two lines intersect. So above this line would be like everything up here, above the red line, right? Everything above the red line. Now, final answer. You guys have done this in class with me. Where do your two red and purple shades intersect each other? That's your final answer. Well, you'll notice actually in this little area right here, you have shading of both red and pink. So this yellow highlighted little triangle, any values in this yellow shaded area will actually solve so that she doesn't work over 15 hours, so her parents will be happy, but she can make more than 66 bucks, which makes her happy. Okay, and so that's kind of the idea today. So you guys have one homework problem to practice. I put a worksheet in today's agenda. Go ahead and try that out and see how it goes for you. Okay, if you have any questions, email me or talk to me.